Welcome back, everybody. Today we're going to look at the Pythagorean Theorem. The Pythagorean Theorem is a method that we can use when we are trying to find the length of one side of a right triangle if we're already given the other two lengths. Now, the way that the theorem works is there is a formula that we use to put in values that we need to solve for the missing side. And the formula looks like this. A squared plus b squared equals c squared. So that's the Pythagorean theorem. Now, as you can see on the triangle that we have on our screen here, there are all the different types of sides, A, B, and C. So if we were to assign a value to two of these sides, we would be able to solve the Pythagorean theorem. So let's go ahead and try that. So let's say that we were going to say that A was equal to 4 and B was equal to 3. And we wanted to know what is C equal to. So the way that we would do this is we would take 4 and 3 and substitute those in for A and B. So I'm going to have 4 squared plus 3 squared equals C squared. And then according to order of operations, we just start solving with exponents first. So 4 squared would be 16, 3 squared would be 9, and then I have c squared still. Once again, we move on to the next step, which in this case would be adding 16 and 9 together, which would give us 25. So I have 25 equals c squared. Now we need to remember that we're looking for c, not c squared. So the only way that we can find that is by taking our final step, and what we're going to do now is take the square root of both sides of our equation. When you take the square root of something that is being squared, it basically cancels those things out. So our square root cancels out the squared above the c, and all we're left with is c. And then on our left-hand side, we have the square root of 25, which is 5. So we end up with a total of c is equal to 5. And that's how we find the missing sides of a right triangle. Now, if we wanted to see this a little bit more visually, we can also look at it in this way. So here we have the same triangle, just rotated. And as you can see, on the left part of our triangle here, we have a side that is 3 units long, and across the bottom we have a side that's 4 units long, and that would be representative of what we just solved. Now you remember, when we square something, it means that we're going to multiply that number by itself. So as you can see, if we look at the 3 here, we have 3 times 3 for a total of 9 squares, which is what we got when we squared 3 in our original problem. Same thing with our 4. We had 4 times 4, which is 16. Now we've discovered that this length across the diagonal right here was 5 units. And as you can see, if we were to go ahead and number all of the different units, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 squared is 9. And then instead of going 1 through 16, I'm just going to continue counting. 10, 11, 12, 13, so on and so forth. It's going to take me a while, but eventually we're going to hit the number 25. Here we go, 22, 23, 24, and 25, which is what we discovered when we added 3 and 4, which is 25. Now, if we remember our multiplication facts, we also know that since this is a 5 unit long side, and this is a 5 unit long side, the area inside this triangle should also be 25 units. Which is what we got when we had 3 and 4. So this is just to prove that our formula of a squared plus b squared really does equal c squared. Because 9 plus 16 is 25, which is what we got when we measured out c, which is also 25. So that's how the Pythagorean theorem works, and the next thing we're going to do is I'm just going to give you a couple of triangles, and I want you to try to solve for the missing sides. And actually, now that I think about it, what I'm going to do instead is I wanted to show you one more thing. what happens if we know that, let's say, the length of our diagonal here is 10 inches, and then we also know that the length of the base of our triangle is 7 inches. How do we determine what the missing length is on the other side? Because this is not c squared, we're going to say that this is a squared. C squared is always the angle, or the line rather, that is across from the right angle. So when we solve this problem, it's going to look a little bit different because we're still going to have a squared, that stays there, but instead of b squared, we're going to have 7. So we'll have 7 squared, and instead of c, this time we're going to have 10, so it's 10 squared. Now when we solve this, our next step is going to look like a squared plus 49 equals 100. And then as we solve equations, we're going to subtract 49 from both sides, which will leave us with 51 on the right-hand side. So I end up with a squared equals 51. And just like before, our final step is going to be using the square root. So I'm going to take the square root of both sides, but when I do that, once again those cancel out, there is no square root of 51, so all we do is we just leave it as the square root of 51. So as you can see, it just depends on which side is missing as to where everything gets plugged in. So if one of the sides that forms the 90-degree angle is missing, then you leave either a or b as the variable. If the diagonal, or the longest side of the triangle, is missing, then you leave the c as the variable. Okay, so now let's actually try one. I'm going to give you a problem and I want to see if you can solve it. So here we have our two practice problems, and I'd like you to pause the video and see if you can solve these on your own. Okay, so let's try solving this first one on the left. First off, our formula is a squared plus b squared equals c squared, and remember that our diagonal across from the 90-degree angle is always c, so that's going to be our missing variable. So I'm going to have 5 squared plus 12 squared equals c squared. 5 squared, of course, is 25. 12 squared is 144. And that's still equal to c squared. 25 plus 144 is 169. And that's equal to, again, c squared. And then my final step for this problem would be to take the square root of both sides of the equation. So the square root of 169 is 13. So I end up with 13 equals c. So that's my answer to my first problem. Now I'm going to move over and solve my second problem. And this time I have a squared plus b squared equals c squared once again, but this time I'm missing one of the sides that forms the 90-degree angle, and we're just going to say this time, why not? We'll call that side b. So I'm going to have a squared, which is 5, so I have 5 squared plus b squared equals, and in this case 8 is my c, so I have 8 squared. My next step would be to turn these, or use the exponents and solve for that. So I have 25 plus b squared equals 64. And I'm now going to subtract 25 from both sides of the equation so that I can isolate the variable b, so that I'm left with b squared equals, and that would be 39. And then my final step, just like in the previous problem, would be to take the square root of both sides. So I'm going to take the square root of b squared, the square root of 39. Those will cancel out, so I'm left with b is equal to, and there is no square root of 39 that we know, so we're just going to leave it as the square root of 39. So there you have it, solving the Pythagorean theorem.